Okay, this is problem number 2 out of Thomas's Calculus, section 5.5, and this is about integration with substitution. And this is actually where I think it starts to get really interesting. You're not just using formulas anymore, you're kind of using your brain. And basically, and I think in these problems they actually gave you the substitution to use. I don't like that, it takes all the fun away. So we have the indefinite integral of x times the sine of 2x squared dx. And the thing to remember here is at this point in your calculus career, you don't have any rules for evaluating integrals of products or quotients. And therefore, you have to pretty much rewrite them. And even, well, I don't know, you might want to use a tabular method in this. But anyway, I wouldn't. I think it's just easier just to use your substitution. And that's what we're going to do. So what we need to do is we ask ourselves, what in this function right here is the derivative present somewhere else in the integrand? So I look at x. Well, you know, the derivative of x is 1, and yeah, 1's in here, but that wouldn't really do me any good. I'd still have u, and then I have to rewrite this in terms of u. But what if I let u equal 2x squared, and then I say that du equals 4, because 2 times 2 is 4, x dx. And then I look here and I say, well, I have an x dx here, so I can actually say that 1/4 du equals x dx. And I can rewrite this as, let's say that implies that I can rewrite this, well, x dx is now just 1/4 du, and sine of 2x squared, well, u equals 2x squared, so I can just replace that with the sine of u. And then now I know the integral of the sine of u du. So that's constant 1/4. Functions whose derivative is the sine of u is the negative cosine of u, and then that'll just be plus c. Now I need to go back to values of x, as that's what I started with. So I'm going to have 1/4, and that's going to be minus times the cosine, and u equal 2x squared plus c, and that's how you do it. And this is one method. There's another method here that's based on the same thing, and I'm just going to go ahead and do it right here because I'm not sure how you're going to be shown. And there's several ways to think about this. I kind of have fallen into liking this, but I actually learned this other way that's a little more mechanical. And so I'm just going to start over again, and I'll do it in blue, and I hope that's not too offensive, but this is just another way to do it. And actually, some people like it this way, some people like it the original way that I did it. So I'm just copying the problem over. And in this case, I'm going to do the same thing. I'm going to let u equal to x squared, and I'm going to take the derivative. I'm going to say du equals 4x dx. But instead of doing what I did before, I'm just going to completely solve for dx. So dx equals du over 4x. So what I'm going to do in this case is I'm just going to completely rewrite. I'm going to say the integral of x times the sine. Now I'm going to make 2x squared into u because I said it was, but I'm just going to replace dx with du over 4x. And some people like this. And now it kind of becomes kind of like algebra. We just get this x over x situation, and I'll bring that 1/4 out in front, and I have 1/4 sine of u du. And I notice at that step I get the same thing right here, and it takes an extra step, I guess, but some people see this a lot easier, and it is very mechanical, and I'm not going to knock it. I think it's really good. So I have 1/4 times the function whose derivative is the sine of u, is the negative. Oh, it's the negative cosine of u, not the negative sine of u. Oh, I don't know why I'm not getting the eraser. go. It's the negative. The function whose derivative is the sine of u is the negative cosine of u. And we'll add that c. Don't ever forget that c. So we have negative 1/4, and then subbing back in for u, 2x squared plus c, and we get the same thing. So those are two different methods. I'm probably going to do this method, the first method that I showed, because in the rest of my videos, because I kind of like it a little better at this point in my life. So that's the way I'm probably going to do it. But this method is really good. In fact, I almost suggest you do it this way, but I don't know. Both are good. Some people see it one way better. Some people see it